Well, I think we can go ahead and get started. We have a guest speaker today. He is Mr. right now, but will soon be Dr. William Rose. He's finishing up his PhD at the University of Tennessee. And I'm just going to take a quick look. He's from Texas, more or less, in that before he was in Texas, he was in Michigan, and then moved to Texas just before he started high school. And then got his master's degree at the University of North Texas. But he hesitates at calling himself a Texan. So
that's right.
Don't rule that. Don't hold any Texan issues against him. But anyway, he will be talking today, as you see on the slide here, about process strategy and maybe some capacity decisions, but primarily process strategy. So, Mr. Bill.
Thank you, Dr. Seibel. Morning. Morning. Like you just heard, my name is Bill Rhodes. I'm finishing up my PhD at the University of Tennessee. And I'm out here just kind of see what's going on in Arkansas State, let everybody know what I'm about, and they're letting me come and talk to a class. So thank you for letting me come and talk to you. And before we get started on the lecture, this is just one of my habits with teaching a class. I like to start off 5 minutes or so talking about what's really going on right now beyond just class topics. So what's going on in the news, and how is that going to affect your process strategy or a supply chain manager in general? So, has anybody seen anything on the news or on the internet, read something recently that you thought, you know what, I'd like to talk shop about this?
Net neutrality has finally been pushed forward. That'll affect the internet and internet transactions a little bit.
Okay.
And a lot bit, and internet providers.
Okay. So yeah, if you're a service provider and you're looking at your operations, net neutrality is definitely something to look at.
Right.
Anything else? I read this morning that several labor unions are coming together and filing a lawsuit against the state of Wisconsin about right to work. Has anybody heard about that? I don't want to get into politics, but if you're working as an operations manager, as a purchasing manager, a process design professional, how does something like labor union issues impact what you're doing?
Right? How does it not?
Right. It's going to hit your costs. It's going to hit your suppliers. Right. So Anheuser-Busch is looking at what's happening up there because it's going to hit Miller. Right. So a lot of things to think about, a lot of things to discuss. Let's talk today about process strategy. So first off, what do I mean when I say process strategy? What do you think about when you hear that term? By the way, I like discussion in class. I'm not asking rhetorical questions.
Oh.
Sorry, I guess I should have cleared that. What do you think? Let's break it down. When we talk strategy, it's our approach, right? It's how we do what we do. Now, when we're talking processes, it's, in this case, transforming resources into something a customer wants. It's changing that form. So really the idea with process strategy is how do we take raw materials and components and meet customer requirements? How can we do that? And so it hits just about everything that you're going to work on. There's got to be some kind of process. And we want to be on the same page. And you're going to have to talk to your boss about, well, here's what we should be doing. And people are going to disagree with you. So these are just some of the ideas and the rules that go into planning your process strategy, some of the tools you can use. So first off, let's start really broad. When we talk process strategy, there's really 4 types of strategies. There's a process focus, repetitive focus, product focus, and then mass customization. We'll talk about each one of these. When you're looking at them, the top 3 fall into this neat straight line on what's called a product process matrix. With a product process matrix, what you do is you look at the product you're producing. And there are 2 characteristics you want to look at. How much are we producing at a time? Are we going to have high volume production where we make 1,000 units a day? Or is it low volume where we're going to wait for an order and we might make 1 or 5, and that's it. So high to low volume versus high to low variability. If we have low variability, everything we make is going to be the same. We're just going to make it over and over and over again. With higher variability, we might make a custom guitar one way one day, and then make another guitar that's completely different, a different color, different weight of the strings, different width of the neck, right? So how variable is that product? So again, we've got these 3, and then we'll talk about mass customization in a little bit. But let's start up here at the top left-hand corner with a process focus. Process focus looks at highly variable but low volume products. So what are some things you think about where one product to the next might be very different, and we're not going to have these massive production runs where we make 1,000 of the same thing? What are some products that fit into that category?
A yacht.
A yacht, right. I'm not going to go and run to Walmart and go to the yacht section and pick out, oh, well, this is a good yacht. I'm going to sit down with somebody and say, here's what I want on my yacht. And they're going to make one yacht just for me. What else?
Jewelry.
Jewelry, okay. Right, some of the more expensive high-end jewelry, right? I had to pick out an engagement ring, and had to sit down, and they showed me all the neat cut and quality and the 4 C's, right? So my fiance now has her own custom-made engagement ring. Along that same line, when I was trying to think of examples, I thought of wedding cakes, right? I get married in July, so a week from Monday, we go and have a consultation. I made the mistake of calling it a tasting, and I was corrected. We're going to a consultation. We're going to taste these different wedding cakes, and we're going to look at all of their pictures. And we're going to walk outside, and my fiance is going to say, I like this one. And I'm going to say, so do I, because that's my job. Right. And then we're going to call the bakery, and we're going to place an order. And we're going to say, we want 100 servings of white cake with buttercream icing, and it's going to be 3 layers round with this kind of flour on it and a little bride and groom on the top. And they're going to take it to a job shop or a bakery. And in a job shop, you set up multiple stations, right? In the case of a bakery, you'll have all the ovens in one spot, all the mixers in another spot, a table where you can do all the decorating in one spot, a spot with all of the different cake tins, the sizes and shapes. And they're going to go through, and they're going to start at a mixing station maybe, and they're going to put ingredients in and use that mixer. And then they're going to take that mixed up dough and put it in cake pans. And then they're going to take it over to the oven. But if somebody else calls the next day and says, well, we want cupcakes, then they might start at the mixing station, but they go over to a different spot and put it right in the oven instead of having to put it in different tiers, right? What are some other examples of job shops outside of a bakery? What do you think?
Repair shop.
A repair shop, right? A machine shop or an auto shop where you've got your drill presses over here and your milling machines over here, or you've got the jack for the car over here, and over here is where we mess with the tires, right? What about a hospital? Right? That's a services job shop. You go into the hospital, you might start in the ER and triage, and then go over to cardiology, and then end up in recovery. Or you might come in and go into the orthopedic section, right? So why do you think this works for high volume or high variety, low volume products?
In a different way every time. Not guaranteed you would sign on.
Right. You're going to do it a different way every time. So now I know exactly where my ovens are. I know exactly where the lifts are for the car. And I can go over there and know this is what I need to use it for. Right? Any drawbacks with it, do you think? What are some of the costs you have to deal with, or some of the cons?
Yeah, it's slower than building a standardized product or
Right.
service.
It's going to be a little slower. I've got to figure out exactly how to make this part. I have to figure out exactly what's wrong with this patient and the right process to deal with it.
Each customer comes to you with an individual problem
Right.
instead of you providing a general solution to a problem.
Right.
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 Really specialized in, they probably have to do all of the things, but they're not really specialized. You just have, like, understanding, but you don't really.
Right. You have to have some very highly skilled, specialized people working for you usually. Right? So with a job shop, you've got high flexibility. You can make something new every time. But you have very low equipment utilization. Right? When we order our wedding cake, they're going to use 3 round cake tins. They're not going to use the square ones. They're not going to use a second oven or this kind of mixer. Right? When I go into the hospital, I'm only talking to 1 or 2 doctors instead of the entire army of doctors that's there. Okay? So what questions do you have about job shops for that process focus? All right. So let's talk about repetitive now. It's kind of middle of the road. Medium variety, medium volume. What are some products where it's not just everything's exactly the same? There's some variation, but not as much as that custom yacht. And we're not making 1 million pieces, but we're making more than 1 at a time.
Well, when I worked in assembly at Hytrol, we
Okay.
built conveyors. Now each conveyor that a company orders is designed specific to their factory layout and everything. But in assembly, we just get, the pre-cut steel comes, everything's generally the same. We use the same tools in our stations.
Right.
Even though the end product turns out a little bit differently, the difference is, well, I built a conveyor that was 4 feet wide instead of 2
Right.
feet wide,
But the process was the same
The
at your
process is
station,
the
and then you
same.
sent it to the
Yeah.
same. Right.
all the way down.
What else? So we've got conveyors. Any other thoughts?
That's what I'm thinking.
Oh, say again?
I said, that's what I was thinking, the same thing, like they're doing it back,
Mhm.
they're doing it back, and this back,
Right.
it's similar to this back, but it's different, so you give it a different way.
Right. So you can look at fast food. It's the same way. Right? I'm going to make everybody hungry by the end of this class. And it's over at noon. This is going to be awesome. How many people like to go to Chipotle? I chose Chipotle because they've got this assembly line right in front of you. Right? It's the same at McDonald's. It's just in the back room. So you go into Chipotle and you see this assembly line. So a repetitive focus is that classic assembly line modular production. You walk up to the first module and they say, what do you want? I want a burrito, I want a bowl, what have you. And they take a tortilla and they steam the tortilla, or if you want a bowl, they don't. Right? So there's some variation, much like it's a 4-feed or a 2-feed. Then they move into the next module and somebody says, what kind of rice do you want? What kind of beans do you want? And then they move into the next module and they say, what kind of meat? And then another module. And every time someone makes a product at Chipotle, it goes through that same assembly line. But there's some variation that allows them to offer a little variety. And they're not going to make 1 million burritos and send them out. They're going to make it 1 at a time, or a small batch at a time. So what do you think about this? What are the pros and cons of a repetitive focus? Why does it fit with that middle of the road piece?
It's really fast, or a lot faster than specific orders, but it allows your customer a degree of customization that leaves
Right.
them more satisfied.
Right. So you lose. Oh, go ahead.
You have limited cost and prep because it's all the same ingredients, it's just mixed up differently.
Right. So you don't have to have as much variety as that customized, that process focus. Right? So you have a little lower fixed cost especially. It's a little bit faster than that process focus. It's a little bit slower than the next one we're going to talk about. Right? So it's that great middle of the road option. So what questions do you have about a repetitive focus? All right, how about this last one, product focus? Low variability. Everything we make is going to be the same. And we're going to make a lot of high volume. So what are some of those products? He's holding up a mechanical pencil. That's right. What else? I chose big pens, but all your school supplies. You know, you might get a custom pen for graduation or something, but when I go to Walgreens to get cheap pens, they're just going to make 10 and stick it in a bag, and 10 and stick it in a bag, right? Things like chemicals, a lot of time, or diapers. As long as we have babies, we're going to need diapers. We're going to need a lot of them because babies go through a lot of diapers, right? Peanut butter. I've been eating peanut butter and jelly sandwiches since I was born, right? And it's been around since the cavemen, and it's always the same. You go to Walmart, you're going to see a jar of Jif creamy peanut butter. Or you're going to see a lot of them. You're going to see jars of crunchy peanut butter. And they're always going to be there. And they have a 10,000-year shelf life. They survive almost as long as Twinkies, right? So we can just make a whole mess of peanut butter at one time and know that it's going to be eaten. So we can use a continuous process where we have just lines that run creamy peanut butter all day long. Now, if you look at this diagram, it's a little bit different than a job shop. Right? With a job shop, you had all of the A machines in one spot, and all of the B machines in another spot, and you moved to whichever machine you needed at the time. When you get into product focus, though, you have an A here, but you also have an A in a different line. It's organized by the product instead of the process. So both creamy peanut butter and crunchy peanut butter need a machine to put the peanut butter in the jar. Both creamy and crunchy need a machine to screw the top on and stick a label on it. But instead of having the putting the peanut butter in the jar station, and anytime you make a jar of peanut butter, you have to go to this one same station. Now we've got a line that has all the machines we need to make creamy peanut butter and all of the machines we need to make crunchy peanut butter. And the two don't cross. And we can just make millions of jars of peanut butter. We don't have to stop if we don't want to. So what do we get out of this that we don't out of the other ones? Why do we use this for something that's high volume, low variety?
It's standardized. You can, whatever you want, page, you want, find, they
Right.
have things all that.
Right, it's standardized. If they don't have the peanut butter I want at Walmart, they're going to have it down the road at Kroger's, right? I'm sorry, what did you say?
It's cost effective.
It's very cost effective. We're utilizing that equipment like crazy. That's not sitting idle when we're running the production line. We don't have to pay for high-skilled labor. Right? All I need to know is how to run this one drill press over and over and over again, all day long. I don't have to be a millwright that can do anything with a milling machine. I need to know how to do one operation over and over and over again. I can automate this process much more easily. Right? So what questions do you have about the product focus or that continuous flow? Okay. So those are our three basic processes that fit right along this nice line. But we got two blank spaces on the product process matrix. This first one down here in the lower left, low variety, low volume. Often that's avoided. If we try and build a product that's got low variety and low volume, we can't raise our price to customers because it's not a custom product. But we're not going to sell enough to get economies of scale. So we want to try and push higher variety or higher volume. But what if we can get up here? High variability and high volume. That's where we get into mass customization. Are there any products you can think of that offer both high variability and high volume?
Cell phones are a big one right now.
Okay, cell phones. Right.
Nike tennis shoes have it.
Nike tennis shoes, right? You can design your own Nikes. Now, there's some of it's the same, right? They're all going to have a sole. They're all going to have laces. But you can put whatever design you want on it. I used converse in mine. The idea is you can take pieces of all three of these and mix them together. You can take this modular design of that repetitive focus, but if we can do it with a higher volume and find a way to make it efficient enough that we can still offer variety. That red is not showing up very well on the side. But hopefully I can see it real well on this computer screen, so if you look up the slides later, you'll be able to see it. But we take pieces of all three of these and mix them together into this mass customized product. So you can design your own Converse shoes. You can go to Build-A-Bear, right? They're not just making a whole mess of brown teddy bears. They're offering you some options. You can dress your bear up however you want. And the big company that a lot of people think of when they think mass customization started in the 90s. It was Dell. Dell was a powerhouse because they figured out mass customization. We can give you 3 different screen sizes, 2 different processors, different speaker configurations, right? 10 different colors. And so you take all of these modules, and there are thousands of combinations you can make. But they've set up their modules so that we can really quickly take this screen size and this processor and put them together. So they still offer quite a bit of variety, more so than the competitive or the repetitive focus or continuous processes. But they do it much more efficiently than that process focus. Okay? So those are our 4 types. What questions do you have? What thoughts do you have on, if you're designing a process, which type you want to use? Okay. So that's that really broad focus. Now, let's say you get your degree and you get hired on as an analyst or a manager, and your boss comes up to you and says, we want to make a new product line. Here's what it is. I want you to go out and research how we should set up the process. You're going to sit down at some point, have a meeting with your boss and your boss's boss and these investors and all these other people. You're going to have to sell them on, this is what we should do. And I hate to break it to you, but you're not going to be able to sit down and say, well, I looked at the product and Bill says we should use process focus. So they're going to look at you and say, who's Bill? Right? So you got to start thinking about what you want to do with it. And they're going to ask you some of these questions. First off, what do we want to get out of this process? And that comes down to what product are we making? Are we going to compete by offering a lower cost product? Or are we going to compete by offering better differentiation, higher variety? Are we going to give somebody a Ferrari or a Ford Fiesta? Those two are going to have very different situations. They're going to look at you and say, okay, can we get rid of some of these steps? You guys talked about value-added versus non-value-added processes. So when you start looking at process design, you have to look at where's our value add and how can we make this process more lean? How can we get rid of some of this waste? They want to say, does this maximize customer value as perceived by the customer? So this isn't just, can the customer get it cheap? If you're looking for a Ferrari, the value is not in the cost. It's in the fact that you own a really cool car. Right? So you've got to stop and think about, how are we competing, and is that what the customer really wants? Because it all comes down to, are we going to win orders with this process? If we run this process, is that going to get us more customers than running a different process? So some people are going to ask you these questions, and somebody else is going to sit in the back and say, well, show me the money. Right? I don't care about winning orders. I want to make sure that we're doing this as efficiently as possible. So you got to know these questions, but you can also use what's called a crossover chart. The crossover chart looks at the volume you're producing and how much it's going to cost to produce that volume of product. So with every one, you've got a fixed cost and a variable cost. And you can outline as many processes as you want on this crossover chart. I'll show you what I mean. We've got process A. Fixed cost doesn't change regardless of how much we make. It's a fixed cost. But you can see this really steep variable cost curve, right? So when we combine fixed and variable costs, whoa, that's a smart one. We get our total cost for process A, right? So this one's got low fixed cost, high variable cost. This might be that process focus, right? And then we can say, well, what about process B? If we use a repetitive focus, this is where our fixed costs lie. And the cost curve, the variable cost curve, doesn't go up as steeply. And then we can put process C. So let's say that's a product focus. High fixed cost, but the variable costs go up much less for each unit of volume. So now I can show my boss, here's our total cost for each process we look at. For every unit of volume, here's my total cost. And the really cool thing about a crossover chart is then I can look at where the total cost curves cross each other. You can see right here, 2 lines. These associate with specific volumes. To the left of the first line, my lowest cost is process A. Everybody see that? Between the 2 lines, process B gives me my lowest cost because it's crossed over. So I can sit down and say, how many units do we want to produce? And if they say 10,000 units, which process should we use?
C.
C. It's the lowest cost on this side of that line. If they say 1,000 units, how many or which process should we use? A. Right? So it's really easy. You look where the lines cross, and those are your cutoff lines. Questions on this one? I know it's kind of complicated now. You know, if you try and just draw them out without all the shading, it gets a little easier. Okay? So now we've decided on a process type. Process, repetitive, product, or mass customization focus. Now let's talk about actually designing that process. We've got a few tools that we can use that help us look at the process in general and make some decisions based on that. Okay? So we've got flow diagrams, time function and process mapping, process charts, and service blueprints. And each one serves a different purpose when we're trying to figure out how to design and improve a process. First one's a flow diagram. And all a flow diagram does is lets you map out the entire process on one piece of paper, or a big piece of paper, or a whiteboard. And so you point out everybody that's going to touch the product or a resource, and everybody that's going to share information. And you lay it all out, and you use arrows to show material flows and information flows. So it's not just, well, it's going to start at this machine and go to this machine and go to this machine. We're going to have to talk to the customer from time to time. So we need to know that information. We're going to need to tell accounting how much to charge the customer. So we've got to worry about both material and information. So how can we use this in process design? And it's fairly self-explanatory, right? It's going to show everything that we need to know about this process from 20,000 feet up. From here, then, we can move into a time function. And I am really sorry. Can everybody see kind of the red on here? It's hard to see, I know. But the idea with a time function map is we've got everybody that's involved in making this process or product. And in each of these squares, we show, first, we're going to order, the customer's going to order the product, and sales is going to process the order. We can see down here it takes 12 days to do that. This might be a little bit older, right? I remember when I was younger, you'd get a paper catalog in the mail, and there'd be an order form in the back, and you'd have to fill out the order form, put it in an envelope with a check, and send it off through the mail. online ordering has probably shortened that 12 days quite a bit. Then it goes to production control, and it waits for 13 days while they figure out how to schedule it and set everything up, prepare the line. And then we print our book at plant A, and it sits in a warehouse for 4 days. And then it moves to another warehouse, and that takes a day, and it sits at that warehouse for 10 days. Okay? So we can show every step in this process and how long it's going to take. And this process right now takes 52 days. How can we use this when we're designing our process? Before we even implement anything, we look at this time function map. And we see from the time I order my book to the time I get my book is 52 days. If I sit in class and the professor hands out a syllabus and says, here's your textbook, do I want to wait almost 2 months to get that book? So how can I use this to fix that?
See what process you can use and make it this time thing.
Right.
This time process.
I can look at speeding up some of my processes or even eliminating some.
Look at the ones that don't exactly add value.
Right. So this wait for 10 days in a warehouse, what value is that adding to my product?
It's taking away value from it.
It's just wasting my time. So we can say, here's what we're looking at right now, but here's what it could be. If we can more efficiently work between the customer and the plant, instead of having 2 separate plants, have one, cut out that transport and that waiting time. Talk to a transportation provider so that it's only 1 day and we can offer overnight shipping. All of a sudden, it's a 6-day wait. You just cut off 46 days before we even started working. So what questions do you have about a time function map? Okay. So another tool we use is called a process chart. Can everybody see the colors on here? I'm sorry, I wasn't sure what kind of lighting I was working with. The idea with a process chart, instead of laying it out with a grid for each time and a line for each person that touches the product, we outline every step it takes, and we just make a list of every step in the process. We have these symbols down here. Is this step an operation, or we're actually changing the product's form? Is it transportation, where we're moving it from one machine to another, or one plant to another, or to the customer? Is it an inspection, which is often important? Is it a delay? Do we have a product that's sitting there in a queue waiting to go through a machine? Do we have multiple orders sitting on my desk waiting for me to take them down to the next person? Or is it storage? Is it sitting on a shelf in a warehouse? So this one is with a hamburger, right? And we make a list. First, the patty's in storage, and then we move it over to the broiler, and we cook the burger. Then somebody checks to make sure that it's medium rare or well done, or whatever we want to cook it to. Then we put it on a rack, and it sits in the rack until someone orders the burger. We grab the buns and the toppings and put it all together and put it on another rack. We say order up, we ding the little bell, and then the server comes up and picks up the plate and takes it away. We can draw a line from each symbol. So first it starts in storage, and then we transport it to an operation. And then we inspect it and transport it to the rack. Transport the buns and lettuce to where the burger is. Operate to assemble the order. And we can see that we've got 2 operations, 4 transfers, 1 inspection, no delays, which is nice, and 2 spots where it's in storage. How can I use something like this when I'm designing a product? If I'm working at a restaurant and I say, here's what we're going to do every time somebody orders a hamburger. And you look over this process chart, how can we use this?
You design the layout, see if it's something you make closer, you put it closer together so you don't have to walk as far.
Okay. We can change our layout to cut down these 4 transportation pieces. Maybe I don't need to walk all the way from the broiler or the first rack across the room to another rack. If we're selling 1,000 burgers a day and it takes me 3 seconds to go from one spot to another, that's a lot of time. It adds up. If we've got a lot of delays, how can we cut those down? And so you've got this chart, this list of steps. And you can see we need to work on this transfer to broiler. If we can move that broiler 2 feet closer to the cooling rack, we can cut off 2 feet of movement 1,000 times a day. Any other thoughts on this one? Any questions on this? All right. And then the last tool is called a service blueprint. And I couldn't get a picture in here. It was too complicated. I would have had to use type about 1/2 inch tall in this room. But if you look in your book at figure 7.9, and the figure might have changed. I had the 9th edition of the book, was the one I used when I built this presentation. There is a service blueprint. With a service blueprint, it shows you who's in control of the process at any given time. There's 3 levels. The example they give is an auto service station. So it's that repair shop you talked about a little bit ago. So a level 1 process, the customer is in control. The customer has to decide to bring their car into my service station. I'm not going to go out and hijack a car and say, we need to repair this, you're coming with me. Right? I might be able to do some advertising or put up a nifty sign, something like that. But the decision is with the customer. That's a level 1 process. They bring it in, and in level 2, I walk out and I say, how can I help you? Well, my engine's making this clicking noise whenever I run the car, so now we're interacting with each other. And I can say, well, you can take a look at it. Okay. So I drive the car into my garage, and the customer sits in a chair in the office, and my techs go to work on the car, and they're checking out what's going on. That's a level 3 process. The customer no longer has control over what we're doing. They're sitting there. We might be sitting around playing cards. We might be looking at their car. Then I come back and we go back to level 2 and I say, here's the problem we found. Here's how long it'll take to fix. Here's how much it's going to cost for parts and labor. So we're interacting. Then it goes back to level 1 when the customer says, nope, I'm taking my car and going home. Or, yeah, fix the car. Does everybody see the difference between 1, 2, and 3? How does this work when we're designing a process? How can we use this?
We want to see what level we need to improve to satisfy our customers.
Okay, we can look at which level we want to improve. Now, which one would be the easiest for us to improve as an operations manager?
The one that we're in control of.
Right. We want to focus on fixing level 3. Changing level 1, that's probably something marketing would say, yeah, we want to focus on level 1 because their job is demand management. But if I'm the guy running the service station, I want to focus on level 3. Looking this over, you guys are playing cards while the customer's sitting in the office. We need to change that, and I can change that quickly. Stop playing cards and look at the car instead. Right? I might be able to change some level 2 by training my customer service representatives on more efficient conversational techniques. Don't walk out and say, no, I was thinking about it. Know what you're going to tell them. Right? It's much harder to change level 1 than it is level 3. So it's another way to map out your process and figure out where to focus your improvement efforts. So what questions do you have about these 4 tools for process design? Nothing? We're good? All right. So now we've decided on a process type. We've looked over the design and figured out where we can improve. So now let's talk about these 8 areas of technology. These have been advancements that have come along that have changed how we look at process design. So the first is machine technology. When I say machine technology, what are some advancements that you think of when you hear about machinery in process design or in manufacturing processes? Are we using the same stuff we did 100 years ago? What's changed? We've got a couple of pictures up here, right? This first one is it's a cutting tool. It uses a high-powered water jet to cut a design in metal. We didn't have that 100 years ago. If you wanted something cut into metal, you had to chisel it out or etch it out yourself. This one's a 3D printer. Has anybody seen a 3D printer before? One of my professors has a small 3D printer on his desk, and he just loves making these little gizmos just to show us he can use it. How has that changed what we do in process design? How's that changed manufacturing?
Just have one operator.
You need an operator that knows how to do it, so there's that skilled labor component.
Before you would use molds and cast, whereas now you would just put it into something similar to a CAD design and it'll print it for you.
Right. I can design just about anything and it'll make it. There's a video online that showed how 3D printing could be used at the International Space Station. We don't have to send up every possible size of wrench and screwdriver and panel that they need. We need to send them up with a 3D printer and enough material to make the tool that they need. Okay, we need a wrench. Let's program it. We'll print out a wrench. Right? We don't need to transport a bunch of material, finished goods. Now we can just print it out. Now 3D printing is not used everywhere, right? But it has changed how we do things. So how does this impact our process design? What are some of the main pros and cons you think of when you think about some of these advancements? Less labor.
The 3D printing, I mean, you have less finishing on the product itself.
Right, you need less finishing. It's much more precise. So there's less waste usually, less pollution. That takes a lot less space than having multiple machines with multiple operators and a storage area to keep all of our finished goods. So that's machine technology. And my clicker just, there we go. Then you've got automatic identification systems. Has anybody seen one of these little tags in their textbooks? Right? When I was an undergrad and I'd see one of these things, I'd think, why are they putting this dinky little bookmark in my book? I don't know what this is for. This is an RFID tag. RFID stands for radio frequency identification. And the idea is you stick this on any boxes or certain components or finished products that are moving through your factory, and you can set up scanners. So all of these boxes have an RFID tag, and they go through this scanner. And the scanner can read what's in the box, what bin it's supposed to go to, what module it needs to go to on the assembly line. And you don't need somebody with a clipboard that looks at this box and says, okay, that needs to go over to that machine. That one needs to go over to this storage area. You can automate it. So what do you see this helping out with? What do you think?
Inventory.
Inventory management is huge. I'm a logistics person, so I like thinking about warehousing. And we went to a warehouse that stored pharmaceuticals. And all it was conveyor belts. And they all had their tags on them. And something would go through the scanner and it would go down this conveyor belt. And once it went through the scanner, something tripped in that machine that said, okay, when this process box passes this conveyor belt, push it off of the main conveyor, and into its special bin. Right? So it helps with inventory. It removes a lot of human error. It lets us automate. Makes it a lot more quick. Right, so what questions do you have on AIS? All right, this next one, process control. With process control, the idea is to look over the entire system from one spot. So in this case, this is a rotary heating furnace. This might be in a brick factory, or it might be working with plastics, something like that. And we have our furnace, and there are sensors in that furnace that inform this program. Here's how hot it's running. Is it level? Here's how much coolant we have left in a reservoir. Here's how fast that machine's turning, its RPMs. And we can look at it all in one spot. Instead of having to go up to each separate furnace throughout this massive operation and say, okay, that's that temperature. Okay, we're good. That's that. Okay, we're good there. That one looks all right. Oh, there's a problem here. I got to run back over here and get somebody to fix it. Right? So we got all of our information sitting right here. So how does that help us out? What do we use this for?
Managing our equipment.
Right, we can have one person managing our equipment from one spot. Anybody live in the dorms here? You have central air conditioning, or does each room have their own?
Each room has their own, but it can only blow like one thing at a time, so it has to be on heat or it has to be on.
Okay, right. I was a resident assistant when I was an undergraduate, and we had our own central air conditioning system. And if your room was too hot, you had to go down to the front desk and tell the person at the front, my room's too hot. And then I'd have to go up with a thermometer, a heat gun, and point at the window and the middle of the room and the door. And then I'd have to go down and call maintenance and say, these are the 3 temperatures that we have. Can you come out? And they'd have to drive out from wherever they lived and adjust the thermostat because we weren't authorized to. We didn't have the key to that room. My last year there, we showed up after summer break, and there were all these little panels in every room. What in the world is this thing? They said, oh, those are sensors. So now, if your room's too hot, get onto the desk and you say, my room's too hot. They call maintenance. The maintenance guy gets up in his pajamas, sits down at his home computer, gets on the internet, looks at his process control program, and sees, okay, yeah, that wing of the dorm is too hot. Click, and adjust the thermostat. Okay? That's the idea with process control. Now imagine it's not just some young college kid that's angry. It's an entire operation, making 1 million jars of peanut butter a day. Right? How about vision systems? Vision system is just what it sounds like. It's a bunch of cameras usually. Okay? So in this case, this module has something like 20 cameras pointing in different directions. Product goes into it, and they all take a picture. And we've designed this product and told our vision system, here's what it should look like. From this angle, you should be able to see that it's this shape, and it has 3 holes drilled in it, and it's rounded off here. Takes a picture and it compares. And if all 20 cameras say, yeah, this fits within the specs, move it on. But if one of those cameras says, I'm supposed to see 3 holes and there's 4, it's going to kick that product out and raise a red flag. This one's used by pharmaceutical companies to make sure that every box that runs through is actually their product in that warehouse. So they're avoiding counterfeit pharmaceuticals. What does this do for us? Why would we want to think about investing in a vision system?
Quality control and liability reasons.
Quality control and liability. Why can't we just have somebody sit there and check everything out?
Human error.
Human error, right? I might not be able to see as well as these cameras can the microscopic differences if we're working with microchips. I can't just pick it up and say, yeah, that looks good, right? Or if I'm the inspector that's checking out kids' toys, and my job is to sit there and make sure that every dolly doesn't have sharp edges, and I'm sitting there and I'm looking, okay, yeah, that looks good. Yeah, that looks good. Oh yeah, I saw that football game yesterday. That was really cool. Man, I didn't see that play. I just let 3 pieces go off without really looking at it. If I'm really tired, I might miss something. These vision systems just do the same thing over and over again. Right? They don't get bored with it. It's their job. Any other thoughts on vision systems? Robots. This has been a huge change for us. Right? So a robot is a machine that can change the form or location of a product. How has this changed the way we manufacture?
Reduce labor costs.
It's reduced labor costs like crazy. My grandfather spent 30 years working for the Trenton engine plant up in Detroit, Michigan. They made engine blocks for Chrysler. And he had one employee whose job was to stand at the end of the assembly line. And when a pallet of pieces, big metal pieces, would show up, that person's job was to take this engine block that had just been formed, pick it up, and put it on the assembly line. Day in and day out. Pick it up, put it on the assembly line. Pick it up, put it on the assembly line. She came to him after a couple of years and said, Mr. C, this is my mom's dad, not the Roses. Mr. C, my back hurts. Can we get a crane or a winch? So he had to spend money so that she can, they'd bring it up and set it down. Her job was to pull the cord and put it up. Right? Well, a robot's back doesn't hurt. It can take on all this stuff that we can't pick up. We can put it in a dangerous position, right? We've got these new bomb diffusing robots, right? I don't want to go up to a bomb. If the bomb blows up, it blows up a robot, we don't lose anybody. It offers a lot more precision than a human being. Right? If I've had too much caffeine and my job is to drill these holes into a product, but I've had 5 cups of coffee because I didn't sleep last night, and now I've got the drill and trying to make sure that it's doing it right. Robots don't drink coffee. Right? So what other thoughts do you have on using robots in manufacturing? Good there? Now we get to automated storage and retrieval systems, ASRS. And the idea here is very similar to a robot. In this picture, you can see this big white box. It's actually mobile. So you can put a box on a conveyor that moves it right down to this spot. And you punch some keys and say, here's where I want this box to go. And this white machine moves over however far it's got to go and up however far it's got to go. And puts the box in that spot. Or you say, I need this box. That machine knows where that box is, goes to that box, takes it out, and brings it back down. There are other ones. There are carousels. So you can have this massive, long line of bins. You ever gone to the dry cleaners and seen them use the moving hangers? It's a carousel. I don't have to go through all of these racks of clothes. I can just hit a button and watch it come to me. Right? So how's this changed what we do?
It makes warehousing more efficient.
Much more efficient warehousing. Right? Why?
Stack boxes higher.
Right, you can stack boxes a lot higher. We don't have to worry about the limitations of a forklift. We don't have to worry about somebody grabbing a ladder and having to climb up the ladder and grab a piece and then climb back down. So we can make it as high as the machine will let us. What else?
Labor costs.
Labor costs, human error issues,
Human error.
right? I really wish every university library invested in an automated storage and retrieval system. Because every time I have to find a book, I need a map of the library to figure out where each book is. I go on a computer and I see here's the Dewey Decimal Number HJ535.I16. I write it down. I go up to the floor where HJ books are. And for some reason, the library at the University of Tennessee doesn't flow well. So I'll have my little piece of paper, and they've got cards on each shelf that say what books are there. So HJ, whatever, whatever. HI, HI, HI. And then I come to a wall, and I look at the racks next to it. Why is that CD? Because HJ is all the way back over here. I would love to go into the library, say, here's the book I need, click a mouse button, and then wait. And hey, there's my book. It just showed up. I would love to return a book. Maybe it's got an RFID tag on it. The system reads that RFID tag and puts the book right where it's supposed to be. Because it might be some young person who's been studying all night for finals and is seeing double. I'm sure none of us have ever been there. And then they put the books on the cart, and they got to walk around and put it back on the shelf. Ah, it's close enough. Somebody else comes in and looks at the book and then says, oh, cool. I got what I need out of it. I'm just going to put it back wherever I feel like. You don't get that with an ASRS. Okay, so it's much more efficient. It takes out a lot of potential for error. What are the thoughts you have on automated storage and retrieval systems? Okay. Now we get flexible manufacturing systems. The FMS is really cool. Because what it does is you can kind of see this line right here and a bunch of little doors. And on this line, you've got what look like just steel billet, right? Just big chunks of metal. And you can program in using CAD or CATIA or whatever program you want to use, a computer numeric controlled program. You can say, I want this chunk of metal to look like this. So this conveyor moves it and it puts it in one of these little cabinets. And if you walked inside that cabinet, it would scare you to death because it's just a bunch of pointy objects pointing at you. Because it's all tools. And you say, here's what I want it to look like. Goes into the cabinet, and this flexible manufacturing system runs all of the tools the way it needs to. It cuts off this part, it drills a hole here, it adds this piece on and screws this into here, and it comes out finished. And it's flexible because you do that with one piece, and then the next piece comes in, and it's a completely different design. And the machine says, oh, okay, I don't need this bit, now I need this bit. Oh, I don't need to cut it this wide, I need to cut it this wide. And it can change. So you can set something up, program it in, hit start, go home, come back the next morning, and there it is. How do you think this has changed what we do? Has it changed what we do?
Definitely.
We don't need an army of people in a job shop if we've got a flexible manufacturing system. That entire job shop is in this cabinet. Right? This is huge with mass customization. Questions on this one? All right, there's one more, and that's computer integrated manufacturing. The idea with CIM is we can connect everything in the process. Right? So we've got the process control programs that show us how the process is functioning and let us keep an eye on everything. Well, with computer integrated manufacturing, we can even design processes. Right? It's not just a control system. We can design a project in our program, and we can say, we want this part to be made out of this material, and this is the tolerance we're working in, and here's how it all fits together. We can send that right over to our inventory management system. And our inventory manager can then look at it and say, okay, we have that, we've got this taken care of. We need to look into how to process or how to get some of this. And they can send that to purchasing. They can send it to shipping. Right? We can share all of this information just using computers. How does this change what we do? What do you think about that?
Cut that 18-day processing time down to
Right.
the 2-day processing or the 1-day processing.
Right. It chops out a lot of processing time because we don't have an engineer that makes something and then prints it out or draws it up, takes it down over to the process design folks and says, there you go. Walks away and starts working on the next piece. And the process design people say, oh, okay, we got to do this. And, well, that's not going to work. Now we got to go back to the engineers and say, that's not going to work. And they got to redo it. And then we go to the shipping people. They say, well, could you change the packaging so that it fits better in a truck? Well, now we got to go back to process design and back to engineering. Well, this allows us to all talk to each other and share all this information and put in our own tolerances and our own thoughts. So what questions do you have about computer integrated manufacturing or any of the other 7 technology advancements? What do you think? Are there pros and cons overall?
Yeah, definitely.
Are there reasons we shouldn't use some of these? I just stood up here saying, yeah, this is really cool, this is really neat.
If your process
Rather
is simple
drawbacks.
enough, then
Right. I don't need a flexible manufacturing system to put peanut butter in a jar, do I?
you can make rubber bands or something.
Right, if I'm making rubber bands, I don't need all of the possible tools. Okay? So you've got to think about certain factors. We've talked about a couple of them. We talked about volume and variety, right? How does that impact what we do? What do you think? It's that product process matrix we talked about, right? Which type of process do we want to use? If we're making high volume, low variety products, do we need a flexible manufacturing system? Probably not. Right? Technology, we just went through and talked about 8 types of technology and how they've changed what we do. And some of these are more suited to certain processes than others. So we've got to look at what technology is available and what we need it to do. Do we need these pieces of technology? Do we need process control systems if we're working in a small shop just distributing, right? What about cost? We're talking operations management. Everything comes down to cost, right?
It's always about the bottom line.
It's always about the bottom line. So we've got to start thinking about how much it's going to cost us to do something. If we're doing high volume, low variety products, and we're trying to compete on being a low cost provider, every time we want to get some kind of advanced technology or hire new people, that increases our cost and it reduces our profit margin. With a high volume, low variety product, we're working with small profit margins as it is. But we're making enough of a certain product, if I could talk, I'd be dangerous. We can make enough of a product that those minimal profit margins grow. So we've got to focus on that cost. Haven't talked much about this one. What about human resources? What do we need to worry about when we talk HR in process design? Should we worry about it? What do you think?
What are you going to do to displace workers when you install the machines?
Okay, right. We just got done talking about all these ways to automate processes and put a bunch of people out of work. So what are we going to do? Right? There's been some discussion about McDonald's trying to automate more of their processes and get rid of employees. All of a sudden, people are looking up and saying, well, that's great. I can get a burger for cheaper. But then I've got to walk past this unemployed person with my brand new hamburger. Right? What else? How else does HR factor into this? If I'm working on a high variety, low volume product, what process type was I using? Process focus. And one of the factors in process focus is highly skilled labor. So if I want to make a custom yacht or a battleship, I need to make sure that I hire somebody that knows what they're doing. I need to get somebody that's certified. If I'm working with sensitive materials, controlled substances like pharmaceuticals, weapons and ammunition, I need to do a little bit more on the background check than if I'm making pencils. Right? If I'm just using high volume, low variety, I might look at HR and say, you know what? If I do this in the United States, I've got a minimum wage to worry about. I've got to deal with all of these OSHA requirements. I could go to a different country where the minimum wage is lower or the cost of living is lower and find unskilled labor for a lot cheaper. Right? So you've got to think about how HR impacts your process. What about product quality? Where does that come in with process design? Don't we want everything to be perfect quality all the time? Do we? If I'm making Jif peanut butter and one jar out of every 100 is cracked, do I need to go back in and redesign the jars so they won't crack?
Yes.
Or do I just toss that one that's cracked and make sure I have a business system that inspects it? Right? So those are some of those balances and trade-offs you have to work with. If I'm making Ferraris, every one of them better be top quality because I can't just scrap a Ferrari. If I'm making a plane, it's got to be high quality or else I'm never selling a plane again. If I'm making socks, I just bought socks before I came out here. One of them had a hole in it in the package. I'm not going to die because of it. It's just one out of the 1,000 socks that doesn't come through properly. So do we invest a ton of money to make sure that one out of 1,000 socks doesn't have a little hole in it? Or do we say, okay, we'll just deal with it? How about reliability? How reliable is our process? How does that factor into our decisions? Do I always want 100% reliability on everything?
You probably want to be pretty close. Otherwise, you can't make accurate projections of.
Okay. So you want to be close. I'll say you want to be as reliable as is
Cost-effective.
practical,
Right.
right? Because again, if my machine's going to break down once, but I'm in a job shop and I've got 5 saws and one of them's not as reliable as the other 4, okay, I'll go with a different saw. But if I'm making rubber bands and that machine isn't reliable and it breaks down, how much money am I losing by an assembly line or a continuous flow process just shutting down so we can fix this machine? Right? So how much are we willing to invest in reliability? So what questions do you have about these factors? Right? Remember, it's all about balance and trade-off. So we could say we want everything to be 100%, but that might not be physically possible. Or it might be so expensive that we're paying for reliability or quality or human resources that we don't need. So every one of these is a lever you can pull. But the moment you pull one, the other 7 change. So you have to start thinking about, what am I willing to give up to get higher quality? What am I willing to give up to get lower cost? Okay? And that all has to go into that overall process design. And talked with Dr. Seidel before, and I said there's a capacity portion as well, but he said he's going to talk to you about capacity another time. So we've got about 5 minutes left. You guys have any other questions about process design, about those trade-offs, anything like that? Any other thoughts on current events that might have popped in your head now that we've talked about this? All right. Thank you very much for letting me come in and talk with you today. I'll hand it back to Dr. Seidel to finish up.
Thank you very